Greetings from Guide to VDS. Today's topic for discussion is physical properties. And in physical properties, we will be discussing about optical properties in detail. Before moving on to the topic per se, whenever we describe optical properties, first we need to understand two concepts. One is the nature of light as an electromagnetic radiation, how it is perceived by the human eye, how it reacts with the object, and how various shapes and colors are identified. So, only when we understand this concept of visualization from human retina till the brain, we will be able to understand the theoretical concepts of optical properties. So, when we move to the theoretical concept, we need to give importance to color specifically because in dentistry, only when we understand the concepts of color, we will be able to achieve proper aesthetics and cosmetic procedures will be up to the mark only when the color matching is perfect. So, color matching in dentistry, but in this era, it is very proven because patient requires an restoration which is completely matching that of a natural, and you should not be able to identify the same thing as restoration. So that much important is color matching with regards to dentistry. And finally, you will be introduced to few special terminologies which are very important in terms of MCQ and short note point of view. So with this, we'll move on to the topic per se. First, we need to study about the nature of light. As I have mentioned in the previous slide, your light is always an electromagnetic radiation, and human eye is sensitive to specific wavelengths, that is between 400 to 700 nanometer. Whenever you see an object or whenever you perceive the color and shape of the object, it is always the reaction between the incident light and reflected light. Whatever light is falling over the surface of the object and whatever light is getting reflected from the surface of the object. It is with this intensities and wavelengths we will be able to perceive the perfect object and perfect color. So, a general outline on how your vision is being produced. Light from the object reaches the human eye, and in human eye, you can see here it is focused in the retina via your nerve. Your impulses are transmitted to the brain, and in the brain, especially in the visual cortex, your object is being perceived as so and so object and so color, and that's how our brain interprets a particular object. So this is the roadmap of how we perceive an object starting from the retina till the visual cortex. Hope this is clear. And now we move on to the nature of object. In the previous slide, what we saw is how light interacts with human eye, and how light interacts with an object is of four ways. You can see four categories as reflection, absorption, refraction, and transmission. So whenever light is falling on the surface of the object, if there is bending of your light on passing through the surface of object, it is called as refraction. If your light is not passing through and getting scattered in a different direction, it is called as reflection. If your light passes through the object in the same direction, it is called as transmission. And in refraction itself, you can see absorption and diffraction and scattering. What is this absorption? Whenever you see that when the light is passing through, instead of bending, if it is absorbed within the body of the material and you do not find a light source as in refraction, it is called as absorption. In diffraction, it is similar to refraction, but you can see the light passing through and getting scattered in all directions after it reaches the surface. In scattering, you can generally see that your light is transmitted in all the directions, in the direction of your incident light as well as in the direction of your reflected light or refracted light. So that is called as scattering. So these are the characteristics or properties of light when it interacts with the surface. And also in transmission, in regards to dentistry, you need to know that Whenever the light which is passing through the surface is transmitted completely, you have to understand that those type of objects are called as transparent. And whenever the amount of light which is transmitted through an object is only 10% and the remaining 90% is absorbed within the object as in absorption, it is called as opaque. Whenever it is 50-50, 50% of your light is absorbed and 50% of your light is transmitted, it is translucent. So three terminologies, one is opaque, translucent and transparent. Depending on how much percentage of light is being transmitted, how much is absorbed, you have these three different categories. Hope this is clear. Now we move on to the topic per se. So before we move on to the color concepts and theories, we need to understand three dimensions of color, or we call it as Munsell color system. It is called as hue, value and chroma. So this is the favorite MCQ as well as a short note question. You will definitely have this type of questions in your theory paper. You will be repeatedly asked in an MCQ, or you can be individually asked in short note as hue separately, value separately and chroma separately. First we'll move on to hue. Whenever you say hue of an object, it is always the dominant color of the object. What is the meaning of dominant color is whatever your human eye is perceiving on immediately seeing the object is the dominant color. Whenever I see an object and say it as red, whenever I see a cherry and say it as red, the dominant color of cherry is always red. So the color which is perceived by my eye is red. So that refers to the dominant object. So how this dominant or color is being perceived is the red color will be the dominant wavelength which will be perceived by the human eye, and the dominant wavelength will reach the retina and the visual cortex, and that's how cherry is being perceived as red color. So this refers to the hue of an object. Now let's move on to the value. Whenever you talk about value, it is always lightness and darkness. It is also called as grayscale because you will have a scale of lightness followed by increased contrast and followed by darker colors. So you can appreciate your value with this example. See, now you have lemons and cherries. Both are having different hues. Your lemon is yellow in color and cherry is red in color. But still you can compare the value of two different colors because your cherry is something bright. The dominant wavelength of your cherry is having higher intensity compared to the lemon, where the yellow light wavelength will have lower intensity compared to that of cherry. So your yellow is slightly lighter than your cherry. The lighter substances will have higher value. So lemon will have higher value than cherry. So that's how you categorize value. It depends upon the lightness and darkness. So contrary to value, here chroma is nothing but the degree of saturation of particular hue. In value it was lightness or darkness. So we can compare even the lightness and darkness between two different colors. But in chroma, it is a comparison between a single color. How much amount of hue is present, how much amount of your dominant wavelength is present. So this can be easily understood with this example where you can compare banana and lemon. Both banana and lemons are yellow in color, but the hue of your lemon is relatively bright when you compare it with that of your banana. So when you tell about the chroma, you can describe in such a way that your lemon has higher chroma compared to that of your banana. So this is as simple as that. Your hue is your dominant wavelength. Your value is the degree of lightness and darkness regardless of whatever color it can be. You can compare two different colors also. Whereas chroma is nothing but the amount of saturation of your hue in single color, whether the single color itself is brighter or darker. Hope you are clear with hue, value and chroma. This is also called as Munsell's color system. Now we move on to color matching in dentistry. See, I have told you the basic color concepts and theories. With this, whenever you attend a patient in the clinic, And whenever the patient is coming for a crown or a restoration, you need to match your restoration with that of your natural teeth. With regards to dentistry, whenever we choose ceramic crowns, we need a ceramic shade guide in order to match the adjacent natural teeth with that of your restoration. So there are different shade guides available. You can see Vitapen Classic and Vitapen 3D Master shade guide here in the picture. Other than this, nowadays we have n number of shade guides, even digital shade guides are present. So this is of basic concept where you will have color coding. So any shade guide basically will have the color coding of A, B and C, D, where the hue of A will fall in the red brown category, B will be slightly yellow, C will be slightly gray and D is red gray. So this is the basic color coding in your basic shade guides. Nowadays we have advances and we have spectrophotometers also. You can select your shade from that way also. So even though there are newer techniques, the basic form is from your shade tabs or shade guide. So the first terminology what we are going to discuss is Besant group effect. Now what is this effect called? You can read the second line. As the brightness becomes intense, your color appears to change. At low light levels, your rods will be dominant and cones will not be present. Okay, so this is the reason where there is a change in the perception of the color when the room is bright as well as dark. Whenever there is a bright room, you see a color, and whenever the room becomes dark, your rods will become dominant and cones will reduce the color vision. So that's why we have a perception of color change, reason number one. And also reason number two is whenever you look at a colored object for a longer period of time, your rods and cones in your eyes will become strained and you yourself will perceive the color in a different manner if you stare for a longer period of time. So always whenever you shade match or color match with the help of the color tab in your dental clinic, whenever you consider your natural tooth and the shade tab, your protocol is that not more than 15 to 20 seconds you should look at the shade tab and your adjacent natural teeth. If you stare for a longer period of time, like more than 30 seconds, you will have confusion within the color tab itself. Your eye will get strained and it will perceive a different color and your matching will be wrong. See, for example, if you stare over a longer period of time, the same yellow colored triangle is seen as black colored triangle. So this is the reason your rods will become dominant, your color vision will be lost and it appears as a black triangle. So that is the reason you need to do your color matching quick and fast. Next terminology what I'm going to introduce to you is metamerism. So this is the property what you need to keep in mind whenever you do shade matching or color matching in your clinic. So metamerism is nothing but your object will appear to be color matched under one type of light. For example, say if you are color matching in your dental clinic, the natural teeth and your color tab would have been matched and you have given a restoration to the patient. Now the patient is being disposed of from the clinic and when he goes to the natural daylight or sunlight to work, the color matching is not the same what he has seen in your clinic. So this is the property of metamerism. The same restoration is being color matched in office in the dental LED light or your office lighting. But the same restoration is not matching the adjacent natural teeth when the person goes to work in the natural daylight. So in order to avoid this confusion, it is always better to do color matching under visible daylight whenever your office is permitting that situation. You can have a small space in your office for shade matching near your window where you can have your natural sunlight and you can do shade matching there whenever possible. So this kind of situation will avoid your shade mismatch under different lighting conditions. See here also you can see under white light the same yellow ball is appearing bright yellow in color, but the same colored ball when placed under a dimmer yellow light you can see the difference. It is appearing slightly dark brown and slightly yellowish white. So all this color difference can be eliminated if you do your color matching for the patient under visible daylight. Next property is fluorescence. So what is fluorescence? It is the ability of your natural tooth to absorb certain wavelengths, that is in the range of 300 to 400 nanometer from your sources containing UV radiation. So we are exposed to n number of radiations in the electromagnetic spectrum. Our natural light will have the ability to absorb these UV radiations from the range of 300 to 400 nanometer, and this will be converted into light with longer wavelengths. Whenever your tooth is being exposed to dark environment like in parties or disco lights, as you can see in this picture, the absorbed longer wavelength light will be emitted from your natural tooth and your natural tooth will appear to glow. Can you see in this picture? See, the same patient has been replaced with implant and crown in the lateral incisor region. Under the visible daylight, your crown on the implant is being color matched beautifully with the adjacent natural tooth. But at the same time, when the same patient is attending a party and under the neon light in the party, you can see that the same lateral incisor crown which is placed over an implant is seen to be missing. This is because your artificial tooth will lack the ability to glow or emit or fluoresce because it is not absorbing any UV wavelength and it is not converting it into a longer wavelength light. Your natural teeth will have this ability and it will glow. So that is the property of fluorescence, and this has to be kept in mind whenever you restore your teeth in the anterior region, and you should just give a note of caution to the patient that whenever you go under party lights or disco lights, your restoration will be missing or will appear to be missing, and your natural teeth will have that glow. Only when you have a knowledge on this property, you will be able to educate the patient why this is happening and how this can be avoided. So in natural daylight, it is not a problem. It will be beautifully color matched. You should inform this in prior to the patient in order to make the patient less apprehensive. So these are the reasons for you to understand the optical properties, because this much it will help you in your clinic. And your last property is radio opacity. Now, what is the difference between radio opaque and radiolucent? As I have told you, the ability to transmit light and ability to absorb light in the previous few slides, the opaque material usually absorbs light within itself and it appears dark, whereas your radiolucent material will allow the light to pass through and it will appear as light. So whenever you take radiolucent and radio opaque, all these terminologies are used whenever you view a particular thing under radiograph. See here you can see a picture showing restorations which are radio opaque as well as natural tooth with pulp chamber and root canal which appears radiolucent. So, in order to make a restoration radio opaque, you need to add some radio opaque markers within the restoration, like your barium sulfate, your restorative resins will contain your strontium, and fewer heavy metal compounds. These are the materials that will make the restoration radio opaque and will not allow the light to pass through, will be absorbed within itself, and whenever you view under a radiograph, you will be able to differentiate, okay, this is the restoration, this is my natural tooth, this is the margin of the restoration, the margin is good, or this is my root canal filling, the filling is intact. You need to identify the restoration as well as natural tooth. Only then you can be able to make a clearer diagnosis whenever the patient is coming with a complaint after the restoration. So that inherent quality of the material to appear opaque under the radiograph by addition of this radiographic markers is called as radio opacity. So I hope it is a very simple session, and optical properties is an easy topic. Just the basic concepts, your hue, value, chroma, the color matching theories, and the terminologies. Nothing much confusing here. So I think the class is clear, and you can post your doubts if you have in this QR code. And these are the expected essay and short note questions. Thank you for your patient listening.